Hi there, Turgeon here, bringing you physics from afar. These are hints for the egg drop project. I'll go through what the expectations are for this. This should look familiar. Here we go. I want you to use your own words. Somehow, if you keep in mind that you're trying to convince me that you understand this and you did this work yourself, it will come through. I have faith. Convince me. Show me any extra thoughts or notes, any extra explanations that will do a good job of making it clear that you understand these concepts. This is a video. You can make a lot of use of this if you listen and rewind. So don't be afraid if something doesn't make sense the first time. Just go over it again and again. And this is like having the teacher with you anywhere and everywhere at all times. Question is, why do things break? What we have here is you got to understand what's physically going on. What is this situation even involving the egg? The egg starts out at the top. There are three key positions. Top or beginning, what we'll call the middle, I guess, and the end. Now the middle is really like the moment where your device first makes contact. You notice that the egg is somewhere inside this boxy device. Then at the bottom it actually makes contact and this might crack. So the egg actually moves inside if you notice. Notice that it's speeding up on the way down and there's this brief period where it quickly slows down. Now if I were to do this more to scale, it's actually probably something more like this from a pretty high drop. This very, very short period of time where this slows down. So we're trying to learn, if you think about this, like what was this project? This project, I keep saying this in class and you know, just keep working on this until this makes sense. Project was not about electricity. Project was not about the moon. Project was not about free fall, even though I'm going to say free fall. The project was really about momentum. The project was really about what is happening here. This thing I just circled, this is what the project is really about. So let's just break it down into two phases. You got the free fall phase where we're going to focus on energy, but we're only focusing on energy. This is funny. We're only going to focus on energy because that's just a convenient way to get what we really want, which is the momentum. So this is really about momentum and impulse. Some key words to consider. What are all these words? Just pause the video. Just absorb this for a second. But the trick is you want to focus on these big words. Impulse, momentum, force, time. Yeah, sure, kinetic energy is part of this. We're going to do some stuff. People say, you know, I get confused. I'm just so confused. I'm just so overwhelmed. I'm so confused. But I don't know is not okay. You can listen and rewind. You can hear this as many times as you need to. So, step by step, here's our data table from the, it doesn't look exactly like it, but it is this data table here. So here are the columns. Let's go through it. What I really care about is these last three. Change in velocity, momentum, and time. So we're going to have these different heights. I'm going to use 0.8 as an example. I believe in front of class I used 1 as an example, so now you get to see where I'm about to come up with these numbers. What I really care about is a change in velocity of 4 meters per second, a momentum of 20. Actually, the 25 is an error. That's the force. Momentum I'd have to calculate, but I would just do the momentum equation with that. And I really care about the time, understanding what those mean. So let's get into it. So here's the stage 1 calculation. I'm only interested in the 0.8 meters. It's pretty short. I'm interested in this whole thing. Okay, so here's my object of interest. So what I really want to get is the momentum right before it hits. Trying to get the momentum, so I want to get the velocity. How do I do that? I'm going to get the potential energy right here so that I can get the kinetic energy here so I can get the velocity. So potential energy, 55 grams is 0.055 kilograms. Make sure you note all of that. And then the mg h. Again, I use the height just as an example. Just as an example to show you how to do this. And then I'm interested in the kinetic energy at the bottom. So I wanted my 0.44 joules. Now I know the kinetic energy here is 0.44 joules. But Turgeon, I thought you said the kinetic energy here was 0.44 joules. Actually, no. There is no kinetic energy here. It's just kinetic energy becomes potential energy becomes kinetic energy. Plug in the 0.44, 1/2 times the mass of the egg. This becomes 0.0275, divide both sides. You end up getting 16, believe it or not. And the square root of both sides is 4. You end up getting exactly 4 as your velocity. Okay, so what's that mean? Well, that means that my velocity is 4 right before this thing starts to slow down. So what that means is, if my maximum velocity is 4 and my final velocity is 0, my change in velocity is 4. It goes from 4 to 0. Here's all the information I know. We are assuming the egg breaks. We're now going to look at the calculation on impact. This is what we really care about. This should look familiar. Impulse, momentum. Impulse becomes a change in momentum. Put in the F, 25, time is unknown, solve for M triangle V. Divide both sides by 25 because we want to get the time, and the time is only 0.0088 seconds. A way that I'd like you to think about this is that the momentum is building up, and then right here, this is what we're really interested in. The momentum's built up, and we have to gently bring that momentum to a stop. We're going to use 25 newtons of force, assuming this thing breaks. So there's something about the impulse. We have a certain amount. Everybody that drops from this height has a certain amount of momentum they have to deal with. So it's a question of what do we do to bring that safely to a stop. So what we have here is, so if you go back and you do that same calculation, but you do it for 1 and 2 and 3 and 4, you'll get all your numbers to fill in, and you're going to notice something about the times. I'll give you the answer. You will notice that the times have to go up to cope with that additional momentum at each of these stages. Momentum is how hard it is to stop. So if something's hard to stop, you either need a lot of time or a lot of force. But we can't really exert a lot of force on this egg because it can only handle 25 newtons. So if we look at all these pieces of the main equation, and I believe this is question number 5 in your egg drop. If you look at all the pieces, let's go through what each of them really is. Force, time, mass, and change in velocity. It's best to look at this picture again. Let's look at the picture. The force is not the force of gravity. It is the force that is exerted on this egg by your device. Maybe it was paper, maybe it was cardboard, maybe it was toilet paper, something that's pushing up against against the egg. And I want a full description there. So it's a force upward on the egg that is used to give it an impulse to bring it down to 0. So there's a force upward on the egg by your device. And you can even say more about that. Like, how do you think about that force? The time is the time it takes for your device to go from maximum speed down to 0. It's the time it takes for the momentum to be depleted down to 0. It's the time that the egg is hopefully safely brought to a halt, but it's not the time it took to fall. M is the mass of the egg. Why? Because the mass of the egg is the thing whose momentum we are interested in. Therefore, the mass makes sense for the mass to be that of the egg, not the earth, not the stairwell, not the person, not the device. Think about it, it's the egg. The triangle V is the change in velocity, but it's not the change in velocity from the beginning. It's the change in velocity as it goes from having momentum to having no momentum. So now you have all the building blocks to answer all of the questions. Explain in your own words what we were trying to do. If you listen to this video, you may need to listen to this over and over. But you know, that's kind of what we sometimes have to do in class. But now you have this video, so you can listen to it as many times as you need to. Something happens with this time that we can conclude what it is we need to do to drop from greater and greater heights and cope with that extra momentum. This has been Turgeon bringing you Physics from Afar.